Hello, lesson 3 of our sequences and series unit, and this one is arithmetic series. A series is the sum of the terms in a sequence. The sum is denoted as S. For example, the sequence term 1, term 2, term 3, all the way to term number, so any number to end it. The series is term 1 plus term 2 plus term 3 plus term 4 and all the way until we end term to whatever number you decide. And that is the sum of that number, where n equals numbers. Note that sum 1 would just be the first term, sum 2 would be adding the first and second terms, sum 3 adding the first three terms, and so on. So to get from one sum to the next, you add the next term. Sum n minus sum n minus 1 equals the term of that number. And we know that Tn means the nth term, or term n, if you will. Okay, and again, for those of you who don't understand, n, it's whatever number is decided. An arithmetic series is the sum of the terms in an arithmetic sequence. The sum can be found using one of the following formulas. So we had the basic general term in our recall here. And that was our first number of the sequence plus the difference times n minus 1. Now with a sum, we have the general sum term and we have the recursive term. So the n over 2 represents the number of terms. The t1, your first term, is also obviously just the first term. And tn represents the last term. Okay, example 1, determine the sum of 30, so n would be 30 here, for the arithmetic series. So we have 5 plus 9 plus 13 plus 17, and all the way on until you got 4n plus 1. So what do we know here? Our first term is 5. The difference, this is arithmetic, they're adding by 4 each time, sorry for that. And the term number we're trying to get to is 30. Okay, so our ending point, the 4n plus 1, is our Tn. Okay, so we're going to be working with the general sum term here. So we have n over 2, bracket 2a plus d times n minus 1. Okay, so we know n is 30, a is 5, d is 4. So we get 15 times 10. 30 minus 1 is 29. 4 times 29 is 116. And finally, 15 times 126 is 1,890. Okay, so the sum of this sequence, if there were 30 terms, is 1,890. Okay, if you wanted to do it with the recursive term for sum, so we have t1 plus tn, so 30 over 2. The first term is 5. The last term is 4n plus 1. So we have 15. So we collect like terms inside the brackets. 5 plus 1 is 6. So we have 4n plus 6. Okay, and it doesn't matter when you plug in the 30 for the n, but let's do that now. Now that we simplified, 4 times 30 plus 6, and we get 15 times 126, which gives us the 1890. Okay, so it didn't matter which formula we used there. Okay, on to example 2. Find the sum of the first 10 terms in the arithmetic series 21 plus 16 plus 11 and so on. So first thing we do is figure out that the difference here, the d value, will be -5. So a value, the first term is 21, the d value, -5, and we are looking for the sum of the after 10 terms. Okay, because we don't know what Tn is, there's no ending point. We can't use the recursive sum formula. We have to use the general. Okay, so I'm not going to write out the actual formula here. We're just going to start plugging in our information because we've done the formula. So we have 5 times 42 minus 45. We have 5 times -3. So -15. So the sum of this sequence with 10 terms would be -15. Okay, given -25 minus 22 minus 19 and all the way to 32, determine the sum of the series. So first of all, we see that these are going up by 3. Oh, we didn't see that last one. So we have an a value of -25, a d value of +3. We don't know the n value, but we do know that it ends at 32. Okay, so first thing we need to do is find n. We need to know n to find the sum of the series. And we're going to do that with Tn equals a plus d. So this is the general term form that we learned a couple days ago. 32 equals -25 plus 3 times n minus 1. Oops, sorry. So to get rid of that -25, we're going to add 25. So we get 57 equals 3 times n minus 1. Then we want to get rid of the 3. So we get 19 equals n minus 1. Finally, we isolate the n, and we figure out that n equals 20. Okay, from there, we can find the sum because it's asking us to determine the sum of the series. So we can find Sn using either formula. Since we just did general above, let's do recursive here. Okay, because we know the first term, we know the last term, we now know n. So S, the sum at term 20, will be positive 70. Determine the sum of negative 31, minus 35, minus 39, and so on, all the way down to minus 403. So again, we have to find the d value, which is negative 4. Let's write out what we know. A is negative 31. D is negative 4. It ends at negative 403. We don't know how many parts to the series there are. And it's asking us to find the sum. We don't know what that is. So again, step 1 is to find n. So just like we did above, we are going to use the general formula. N games 403. Okay, negative 403 plus 31 is negative 372. We will then divide that by 4. Negative 4, sorry. And we get 93 equals n minus 1. So 94 equals n. Okay, now we know n. So we just did recursive above. Let's find Sn. Let's just do recursive again. We know the n value, we know the starting value, now we know n. And it is a little bit quicker. And 47 times negative 434 is negative 20,398. The sum of that series. Okay, just a little bit more. We're going to show deriving the formula for arithmetic series, just in case you don't know, or you want to know how we're getting to these formulas. Recall that Tn equals a plus d times n minus 1. So the difference, what we're doing from term 1 to term 2 is adding the difference. So we can say that, well, T1 is always going to be the first term, but T2 is just T1 plus D. And the third term would be T1 plus 2 of the differences. Okay, and you would do that all the way. We don't know what the end of this sequence is. It's hypothetical. But you would get, so the end minus 2D, Tn minus D, and then Tn. Didn't need brackets there. Okay. So that's number 1. Make a second equation by reversing the order of the terms. So we're just flipping it backwards. So we're starting with Tn. We have Tn minus D Okay, so exactly the opposite of what we just did. That's the second formula. Now, if we added equation 1 and equation 2 to eliminate the d in each of the brackets, so we'd be adding these, and then adding these, and then adding these, and so forth, all the way down, we would get t1 plus tn plus the second term would be, so the d plus d minus d, positive t minus d will get rid of each other, so you end up with t1 plus tn. And the positive 2d minus 2d would get rid of each other, so we have t1 plus tn, and be the same on the other side. The 2d's would cancel each other out, t1 plus tn, and the last one, t1 plus tn. So there are n amount of the t1 plus tn terms. Each term became a bracket of term 1 plus the final term. And it all depends on the length of the series to know how many of those there are. So we have two sums equals n times t1 plus tn. And we don't want 2 there, we want 1. So let's get rid of the 2. So that's where we get our n over 2 times t1 plus tn. Okay, one other thing or substitute tn equals a plus d times n minus 1. So we need to remember here that t1 and a are the same thing. They both mean term 1. So when we do this, we have Sn equals n minus 2. So we're replacing the letter T1 from up here by A. We're replacing T1 with A. And we're substituting out Tn with all of this. So we have A plus D bracket n minus 1. Okay, so substitute out T1 for A and Tn for A plus D times n minus 1. And that is where, when we collect like terms in the brackets, we have A and A, so 2A plus D times n minus 1. And that gives us the general sum term.